I know, my webcam's closer to me now. Alright, so, ladies and gents, here's one of those times that I'm going to be like very forward with you guys and just admit I don't know quite what I'm doing this year because y'all are the first time I've ever taught this class. Right? Last year I was teaching Math 8, and in Math 8 I know that they've done all of Math 7, whereas you guys haven't, you skipped over a little bit. So have you worked with algebra tiles before?
Yes.
Okay. So we know a little bit about them then, right? So what are algebra tiles used for? Zach, what are algebra tiles used for? Pass. Mike, what are algebra tiles used for? Where is Mike? Why did my cards? Who did this? Oh,
You.
shh. If you are frantically trying to complete homework, please stop. It's real obvious. Ooh, we got people without name tags out. Let's take a pause and make sure we got what we need done taken care of. Who what? The new man with the name. Oh, all right. Is he my brother, Bradley? Bradley. Just checking. I know Bradley's only thing, but my brother Bradley does everything. All right, hold up. Bradley says he can tell us what algebra tiles are used for. To visualize X and Y, I agree there's more. So we can pass it to somebody else, or you can keep going if you don't want to pass it. So, take over.
Algebra tiles are used for boring kids out of their minds.
Absolutely not. If that's what you think they're used for, I apologize for your previous math teachers. Min? They're used to visualize areas. Now, yes, they can be. That's not the only, right? We use them for tons of stuff. Are they only used for quantities we don't know? No. Algebra tiles get used for quantities we know. So I'm giving you a couple minutes to play, but then we're actually going to need to take a tiny bit of notes about these. So if you just dump, now hold up. If you dump your whole bag out, you got to put your whole bag back.
Right now?
I don't care which, like, no, not, you don't have to put it away right now. You will at the end of class. Hey, I'm going to make a request, and this is new. It's hot. I don't know if anyone else feels it, but it's hot. So my room has zero chance at cooling down if the door's open. Because the hallway's super hot. It's 76 in here right now. So if you go out of my class, just please shut the door. I don't care, like, if you need to go to the bathroom, whatever, that's fine. But please shut the door. So, what I want you to do is get out get out one, and if you're making artwork on your desk, please shove it to the side for a minute. I'm not even saying you have to put it away. Just shove it to the side for a minute. Pull out one of every different type of tile. I mean, I don't mean you have to dump a giant pile on your desk, but I'm going to sort and figure out the different tiles that I have.
Oh my gosh. They put.
I'm going to put them on. It must suck to have these tiny little pieces.
Hey! Thank you for the reminder. Guys, the little tiles that are the exact same color of the carpet, please make sure that if these drop, you pick them up. Like, eventually, all of my one tiles are going to get sucked up by vacuum cleaners if we don't try to keep them up on our tables. So please, if they fall, please take a moment to pick them up. Yeah. No. You don't have one tiles in that bag?
Here, I'll give you.
Well, you do. They're just all connected together, right?
Exactly. So I asked you if I should break them apart.
No. That still does not change my answer, Zach. So that just means that somebody, when they put their tiles away, didn't put any one tiles back in there.
Or maybe someone broke them.
So now is one of the times when I'm going to change what I say is like always, and potentially allow us to do something different. You can, if you want, come up, and I'm not done sorting out my different types. You can, if you want to do this on blank paper, we're going to trace all of our different tiles. So if you want to do that on blank paper instead of graph paper, why might, like, can anyone figure out why I might be offering blank is that word when it won't line up?
Poorly designed.
Parallel.
It was in your math notes.
Non-linear.
Nonsense? Yeah, no.
No, non-linear.
Nah, not non-linear. Depending on the size of graph paper that you have, because there's different sizes, tracing these on graph paper is going to make things look worse. So I will tell you, you might be better off to send somebody from your team up to grab a couple pieces of paper, do it on blank paper.
Don't laugh at me.
No, it's very intentional.
Well, they're probably made for children.
I'm waiting for people to stop their whining, and then we'll talk about why it's intentional. But I know that I just got to let the whining whine its way out.
Most educators hate children. They do.
If you genuinely feel that way, I feel sorry for you.
We have multiple teachers who love us very much.
Moss is the only one saying things that I actually want to hear.
Non-commensurate.
All right. Yes! Non-commensurate. These algebra tiles are intentionally non-commensurate, which means they do not line up no matter how many times we multiply them with each other. So first things first. The itty-bitty square tile is our what tile? One. Trace that. Trace that in your notes.
I already traced them in the wrong order.
Trace, I mean, it doesn't have to be first. It's what, this is for you, right? This paper's for you. When we trace that, if we leave it open, like empty, what does that represent? Negative. So if we want this to represent a positive one, we need to shade it in, and if you want to grab some colors, you could even shade it in blue if you want. Or purple, I guess they're kind of more purple or navy blue. Or you could just shade it in, because on your worksheets, it would just be shaded and unshaded. Up on the screen, it might be blue or red, but this is our one tile, specifically positive one tile. Don't choke. Now, Zach had an interesting question. Do I break these apart? What is... No, I mean, that was a good... because his bag didn't have any ones. That's a valid question. And he could. If he needed one tiles, he could. But I don't want him breaking my manipulatives. What is this? What would we call this?
5.
A 5 tile, right? Because it's 5. It's 5 long. One. So, guys, hold on. We're not just tracing these. We're going to label. This was a 1 tile because it was 1 by 1. This is a 5 tile because it's 5 by 1.
So we're doing it by area, not by...
Yeah, these are named by area.
What about these flat 5?
Hey, we'll get there. What?
That's not
No,
5. That's 6.
It's not 6.
That's 5.5.
It's not 5.5.
It's like an X.
Over 5.
Or Y.
Ah, it's like an... Oh, so it's like a variable.
Which one?
Well, we're not there yet. I'm only on the 5 tile. Some people are trying to rush and get ahead of me, but I'm only on the 5 tile so far. 2, 3,
So hard
4,
to
5.
trace these things. Yes, it is.
And then label your dimensions 5 by 1. And this is a 5 tile. I know it's a bit tricky to trace. This is just for you. You can keep going. If you've already traced the 1 tile, already traced the 5 tile, you decide what you think the next tile would be. I would keep working my way up via size.
Chonky tile.
So the next one I would grab is the light blue rectangle. If I was you, the next one I would grab. But I mean, I'm not you. So. The light blue rect. Ooh, good identification. So Moss realized we have light blue rectangle and light blue square. Both of those we will talk about next, but the rectangle is going to be our first one. If we line up the 5 tile against our x tile, what does it look like x is?
4.56.
4.7.
4.5 or 3.5. 3.61.
Now, here's the problem. We can only spend so much money on you guys, right? And if you've been paying attention, Columbus City Schools actually was on strike, right? They hopefully have resolved their strike today, and hopefully your friends who live in Columbus will get to go back to school. But if we had infinite amount of money, I would have had these tiles made out of clay that has not been fired yet, right? Like clay that can still be stretched, or like some of your thinking putty or whatever. Because this X tile, really, I need you to believe me that this is that X tile. Okay, this is 1, right? We're going to call this length 1. You with me? This X tile is not a fixed object. I can make it longer. X can change, right? So like X can get longer or shorter. The 1 cannot change. So this length of X is not saying it's 3.5 or 3.6. That's not what, like, all because it looks like that. You have to, in your head, tell yourself X is actually a flexible length. It's a variable that we don't know. It changes. X could be from that wall to that wall. X could be the distance between my fingers, right? Like, so, you need to write down something that you will remember. X can be any length, right? But the 1 is always 1. So the edge that is short, our short edge is 1. But our longer edge on that tile is X. So X by 1. We call this the X tile. And the area of it is X, because the name of the tile is the area. So then, guys, we want to like play with these tiles together too to see what they have in common and what they have different. What do the square and yeah, I dropped the tile. I'm trying to find it. What do the square and rectangle tiles have in common?
They exist.
The this? What is the this?
I said they exist.
Oh, they exist, sure. Yes. If I put these, do these look the same?
They look about the same.
Well, they have the same size.
They have the same length.
They have the same length.
This is
Or
X by
height,
X.
depending on
Ah, this square is X by X, which means it is our X squared tile.
Oh my gosh. It is X squared.
I think that is a very cool name.
So guys, we can start to put the names inside of the tiles too, but please also make sure you're still notating. This is X length, X width, making it X by X, or X squared. Now, here's the problem. You're thinking, okay, so if X is a variable length that can change, isn't X squared also?
No.
Yes.
Yes, it is.
Here's the problem.
It has to stick in the square shape.
Here's the problem.
We have to use next rectangle.
I only know how big X squared is if I know how big X is. Right? So the only way that X squared is related to X is if X is the edge of your square. Right? So if I shrink my X down to be the edge of the square, then this is true. This is X squared. If my X gets bigger, this is now not X squared. X squared will be bigger.
It could be Y squared.
Or it could turn into a different variable, because if X stays the small x pushed together, then the next most common variable we use, not that we need to, but the next variable we use is this lighter purple tile, which we are going to call our Y tile. So I need to get my other lamp over there. It's hard to see those tiles. Can we undo those, especially because those putty erasers kind of hold germs in them?
What are putty erasers? They're putty erasers. They're erasers.
Some of you guys are getting creative and giving your tiles like little designs, which might help your brain to like, oh, when I see X squared, I see it kind of like. Now remember, if they're positive, I should be shading them in, right? So if my tiles are positive,
Oh,
I should be shading them in either with my pencil or if I want to, especially later if I wanted to, I could color these in like they get colored. Ooh, hold on. We'll talk about it in a minute. You're getting ahead of me. You're getting ahead of me. I'm trying to make sure that we're all... Guys, please quit shouting things out unless you're the teacher, which I don't think any of you are. So obviously, we had x and x squared. So if we have y, a lot of you are already realizing we probably are going to have a y squared. But if your bag doesn't have one, you might be confused right now. So if your bag doesn't have one, you're just missing it. But you should have a purple square. And if you don't, somebody at your table hopefully will. That is the same length as your y length. So this was y long, 1 wide. We call that the y tile. Oh, up here. We forgot to write this down.
Could I please have Anna Blake to the office? Anna, please come to the office for an appointment. Thank you.
That is how we write the x squared tile, because x times x is x squared. All right, so my y tile I'm going to shade in.
So you said drawing the x symbol for multiplication.
Yeah, so we stop using the x symbol for multiplication, right? Because we're using x for variables. A good reminder. So this is my y tile because it's the rectangle, and y squared will be the square. Is y always bigger than x? No. This is why the tiles are still kind of tough. They're nice. These are really nice visuals. But like in your head, you're thinking y is bigger than x, like y squared is bigger than x squared. Don't get that stuck in your head though. It depends on what y and x are. So remember, x could be as big or as small as you want. Same thing with y. So this edge y, making this y squared. Now again, what are the red sides used for? Negatives, right? So we don't really like subtraction actually in this class. We try to avoid it.
Really?
Yeah. Actually, I pretty much will try to brainwash you to convert every subtraction, like away from subtraction. Same thing with multiplication and division. Division doesn't exist.
I love division.
Why?
Guys, I'm not... Guys, you don't realize, like, you have yet to really learn who I am. Are we out of time? No, we're not. Why are people moving? I got, like, 18 minutes left. Oh,
They might
Anna,
have just been late.
didn't you just get called to the office?
Yeah. I need the homework because I don't think I'm coming back.
Unacceptable. I didn't give this to you earlier.
You gave me the homework for yesterday, but I feel like there's another homework for today.
Are you math 7 or accelerated?
I'm excited.
Okay. Have you gotten 2-1-1 yet?
No.
Are you going to be here tomorrow?
Yes.
Okay. You need 2-1-1. And then literally right now, my conversation with you is in the recording that I'm recording class. So then just go check my YouTube channel if you want to see what you missed. Thank you very much.
Hi, and girlfriends.
Anna, you can say hi to yourself.
I was like, hi to the friends. Say hi to future Anna.
All right, and the last tile that you have is this green rectangle. It is not something squared. Because it's not a square. Guys, okay. Now, I blame some of my previous teachers. Because I didn't really understand language. And actually, I had a speech impediment. It's kind of weird because now I talk for a living. But I didn't really understand language. When something is squared, that means it has been formed into a square. You took a thing and made a square out of it.
What?
This can't be something squared. Now, it can have an area of something squared, because then we're talking about little bitty squares. But what this can be is lined up with one of our x lengths. Whether I use x squared or x, it doesn't matter, because we know that's a length of x. What was the purple length? So what, why? Well, because I asked you. So this must be xy.
It's not time for the last one.
So this is y, this is x, meaning this tile is x times y. But guys, I heard a couple of you say it's xy squared. X times y is just x times y. If you say xy squared, you'd be doing x times the y squared, which is not the same.
That makes absolutely no sense.
And then we can shade this in. Yeah, what's up, Liam? You can. So you don't need the multiplication dot if you do not want it. You're absolutely right. You can just write x next to y. And we know a value next to another value is multiplying. Oh, but here's what I was about to show you. A thing from the interwebs.
What's an interweb? The internet interweb. Right there.
Yeah. Is that Reddit?
So, division. Right? Division.
It's not in focus.
I can't. It's just my document. Okay, so this says we should think of the division symbol as a prefix symbol for multiplicative inverse. It might be camera on screen. Sometimes they can't get along with each other. So what? I'm on a Reddit math education page, right? A bunch of math teachers talking about teaching math. So seriously, what we're talking about is getting rid of division. Stop talking about division, because division is just fractions or multiplication by the reciprocal, right?
So I have to forget
Division
long division?
is just a nickname. It's really, guys, so most of the time this year, we avoid subtraction and we avoid division because they're harder. Like math is already hard. Why make it more difficult? All right, so now pack up your tiles, put them in your bag.
I don't know to do long division anyway. I wasn't paying attention for one class in the 4th grade, and now I don't know.
Hey, so if you keep doing that, we're not recording this class. I got two different options. If one class is immature, I can record the other one. Okay, rein it in. I am going to put a collection of tiles on my desk, and you and your teammate are going to figure out how to write the name of that collection, simplified. The simplified name of that collection.
It must suck to have so many times.
Check the floor if you've got a moment, like your tiles already picked up. Check the floor.
Mr. Hudson, I have found an imposter.
You have found what? One square? Oh, one of the clear ones? Yeah, we've got a couple clear sets. They just can't use negatives. That's the only issue, is they can't use negatives. All right, ready? Here we go.
Minerva.
Oh my god, you're the only teacher that doesn't have a growth mindset poster here.
Whoa, we talked about growth mindset on day 1 with my nail experiment lab thing.
We talked about growth mindset
And-
this morning.
and- What?
Foundation.
Day 1 of my classroom. All my posters are still in a stack. Again, 4th classroom in 3 years. I still need to put my posters up.
What happened to the math presentation one from a day ago?
I took them down to make my homework board.
Math
So, thank you to Val. Thank you to Val for pointing out something I forgot to say at the beginning of class. Like, now we're getting into normal procedures, especially if you're late to class and we've already moved on from the start slide. Your plan book is always going to be over here. Okay, so your homework board, and I'll pretty it up a little bit and put like Monday, Tuesday, Wednesday, Thursday, whatever. Like, and I'm going to run tape along the rest of it, but I ran out of electrical tape this morning to box those out. So yeah, 2-1-1 today. Not sure if we'll have homework tomorrow or not. So I haven't decided that yet. Already decided for Math 7, obviously, but you're the accelerated class. So you should anticipate you might have homework on a Friday when Math 7 doesn't, because you have more to cover. Liam?
So the 5 block, could we just do like, since there's 5 ones, just 5 plus 5 and...
You tell me. Could we? My question I was about to say is, what would make this more easy to look at? Well, yeah, for about the one. But what would make all of this? What would make all of this more easy to look at? Sort it.
It's only if you use it. It's only if you use it to say something is that.
I don't know. I think...
All right. So y'all are acting like you're just like pros at this. Fine. 2-4, build collection A on your desk. Once, not both of you, like you and your partner, build collection A.
I wasn't done writing them down yet, though. Okay. Where are we? Why did you take this key away? We don't know what
We both make it. That fly really loves this table.
You should have gotten
What did I
one from the front when you walked in. If you didn't, that's not on me, that's on you.
Imagine if the fly landed on the microphone and all you heard was by ourselves. No. Then you use your own material.
No, I already put that away. No.
Do it. Minerva, use your own material. Because
Well, so my objective here is how do we then, once we lay out a collection,
way more than
simplify it? So if I got 3 x's and a 5 and x squared and y and 3x squareds and 2. We have not used enough random cards today. Leah, what could we do to make this easier? Gosh dang it. See, this is... Did you guys get totally mixed together? I feel like I mixed your decks together at one point. I'm going to have to fix this. Oh, yeah.
Or you could do like you're taking attendance and you could say like,
I think I just literally picked up a stack that didn't work right. And or Zach was in the wrong stack. Maybe that's what happened, is that Zach was in the wrong stack. All right, Nick. I was about to say, I got to sort. Nick, what can I do to make this easier? Like what I have up on my screen, what would make this easier even just to look at?
So, what I was planning to do is, so if you arrange, like, these, the 3 x's,
Okay.
and one of the x squareds, or actually all of the x squareds,
So if I,
kind of a line,
all of the x squareds, kind of put these all together.
yeah.
Yeah?
Another way to do it, you could have, like, kind of just like a straight line of them, and put all the x's, like on top.
So I love what you're doing, like thinking Lego style, but how would I describe what this quantity is I still have two different types of shapes. So eventually we'll be able to talk about this, but this will be kind of complicated to write. I think we should probably keep these separated for now. So how do I, what is this now that I've arranged my tiles? 4x squared. So beneath your A, go ahead and write 4x squared. Because simplified, we have 4x squared. Then we have 3x's. And then we still have our y, and then 7. So combining like terms is always going to simplify what we're looking at. And combining like terms essentially is just putting things with the other things that are the same. Same shape, same size. Try collection B. If you're missing tiles, ask a neighboring group maybe.
After this, we have
Now you could use highlighters or shapes around your
Minerva,
values.
you have a bag. Oh wait, yeah.
There's a lot of ways we could simplify this. Oh, you're still on class. I think you're on homework. I don't really care. You've done what I need you to do. I don't really care.
Oh wait.
So to simplify this, Juliet, how could I simplify this? The wrong stack again. I've got all of my cards over here. Val, how could I simplify this?
3xy 6 plus 6 and then plus 3x squared.
3xy, 6, and 3x squareds, right? 3 different types of terms. xy's, constants, x squareds. Try collection 3, or C, my bad, try collection C.
Good afternoon, Phoenix. Please pardon the interruption. At the class change, could I please see Eric Kim, Cole Bowen, and Christian Gabriel in the office for just a moment? Thank you.
I want to be called to the office just once. I don't know.
Who anyone's name in the office is, so I feel bad.
It's mainly our office is Ron, Sean, and Chrissy. Kind of. So Ron is our counselor. Sean is the principal. Although Ron just goes by Ron, I think. It's Mr. Waterwash, but Mr. Flynn is the principal, and Chrissy is the secretary. And she's Mrs. Cavalucci, but she probably doesn't care if kids call her Chrissy. She's a mom. She takes care of everyone around here. How do I simplify this collection, Liam? Slingy.
Which one's B, D, E, right?
C. I'm looking at C right now.
Okay, I did D. So C is 2 plus 4y plus 3x plus x plus x squared plus y squared plus xy.
Wait. I think I didn't lay out everything. Did we move on from C? No. X squared, 3x, y squared, 4y. Aha, I'm missing my 4y and my xy. Okay. So this is C. Is there anything that needs moved around or sorted? Why? Liam, why do I not need to move anything? Why? Like, previously, it's been like, put these together, right? Or put, why is there nothing to move in this situation? Yeah, they're already grouped up. Yeah, they're already grouped. I hope the side conversation's on what it should be. I'm going to give benefit of the doubt and say it probably is. So then D. Let's see if D is good. 3y, 2 2xy 4x y squared 4y, running out of desk space and tiles. By the way, guys, you can leave your tiles out when you leave, but they need to be back in the bag, please. So they're not ridiculously tempting when the next class walks in. 4y and one more. All right, what sorting or moving do I need to do to simplify this moss?
Okay, so first we got to
Okay, pass. Colin, what moving do I need to do to simplify this expression? All right, y's are all hanging out. Move the ones together. Okay. Yeah, and then that's it. So guys, what we're going to start doing more and more with simplifying expressions is exactly like what we saw here of all of the same shapes, which in math we talk about as like terms. All of the same shapes need to be in the same groups. All right, so now I need to see everyone putting their tiles away in their bags, clipping their papers back in their binders, and then we'll get ready to go. But please, like, maybe work together to try to keep the one tiles from being all over the floor. And then that's it. Thank you guys so much.